Number 3. We're moving in a circle. Let's get everything to meters first. So 50 centimeters is 0.5 meters. There's 100 centimeters in every meter stick. Picture a meter stick. So if we have 50 centimeters, that is half of our meter stick. And if we go 60 centimeters in 1 second, if there's 100 centimeters in a meter, divide by 10. Okay, just making sure. Yeah, you can also just swing the decimal on that, apparently. So 0.6 meters per second. I want to know, what is the acceleration? Okay, you might think, well, it's going 60 meters per second, like constantly. The acceleration will be 0. No, we're moving in a circle. So we have centripetal center-seeking acceleration, even though our linear velocity isn't changing, or the speed isn't changing, the number doesn't change, it's just the direction that's changing. But we do have a value for our centripetal acceleration. So the formula is on your formula sheet. It's v squared over r. So I'm going to take that 0.6, square it, and put it over our radius, which is 0.5. And I'm going to type it in correctly this time. So again, 0.72 meters per second. Oh, and we go back to centimeters. Did I lead you astray by converting everything to centimeters? Okay, what if we left it all in centimeters? So this would be 60 squared. This feels so wrong. Over 50. 72 centimeters per second squared, I guess, in crazy land where you stay in centimeters. Okay, it's 0.72 meters per second squared. That's the answer.